However, it is a pleasure to present the following scientific poster that summarizes the last two practices we performed of the bioreactor engineering course: substrate characterization and solid-state fermentation, right, as it says in the title. The people behind this little project is myself, Leonardo Raá, Jhosué Pinelo, and Solis. Of course, affiliated to the School of Biotechnology Engineering, Faculty of Pharmaceutical, Biochemical, and Biotechnological Sciences, Catholic University of St. Mary, Arequipa, Peru. Well, as a brief introduction, what we did here, what we actually practiced here, was solid-state fermentation, right? SSF, which is basically an efficient way of obtaining products, valuable products, from residue. In this case, agro-industrial residue. By transforming it using biological vectors. Well, in this case, two types of fungi. We use trichoderma for biomass and Monascus fervor for biopigments, specifically acetylene pigments, right? But let's get to the objectives, okay? What we needed to do was to compare this starchy agro-industrial residues for the SSF production of both trichoderma and Monascus. For that, we needed to determine Conidia concentration, we needed to quantify pigment production, identify the substrate with the highest daily productivity, and finally build a homemade solid-state fermentation bioreactor, as well my friend here is going to explain very soon.
A bioreactor was built as seen in the sketch. A two-level tray array was constructed using aluminum rods, metallic mesh, and contact cement, and placed inside a glass jar serving as the main vessel. The lid was fitted with 4 perforated ports for the inoculation, gas off release, thermohygrometer proof, and humidification line. Each tray was loaded with 3 grams of granadilla waste, and the entire system was sterilized at 121 degrees Celsius for 15 minutes. For the substrate comparison, 5 grams of each starchy residue, granadilla, passion fruit, coconut, and rice, were hydrated with 10 milliliters of 0.9% saline and autoclave using the same condition. Pigments were analyzed through ethanol extraction, followed by absorbance reading at 525 nanometers, while continuous quantification was performed by a serial dilution and counting with a Neubauer chamber. Throughout fermentation, continuously monitor the bioreactor microclimate, recording the conditions of approximately 18 degrees Celsius at 41% relative humidity. This integrated methodology allowed us to compare the performance of both fungi across different substrates under controlled SSF conditions.
Our results showed that rice and coconut were the best substrate for fungal growth. Trichoderma produced the highest number of Canidia on these two substrates, while passion fruit and granadilla showed lower values. For Monascus rubber, rice also showed the highest pigment productivity, followed by granadilla, passion fruit, and coconut. In the discussion, we explained that rice and coconut suffer stronger growth because they are starchy, porous, and hold moisture well. These properties help the fungus spread and produce pigment more easily. In contrast, passion fruit and granadilla have more acidic in compact structures, which reduce oxygen flow and slow down the enzymes that the fungus need to grow. Inside the bioreactor, the temperature increased slightly to 18 degrees Celsius and humidity reached 41%, showing that the fungi were active and generate heat, which is normally in solid-state fermentation. This stable condition helped reduce moisture loss and allow better colonization. Overall, the results show that both the substrate and the bioreactor design affect fungal performance. While rice and coconut are the most effective support, the bioreactor also improves growth even on less favorable substrate, showing its potential for lower, low-cost SSF processing using agro-industry residues.
Well, that's pretty much the results. For the conclusions, we got that obviously the tray bioreactor assembly successfully supported our SSF, maintaining a stable temperature and humidity. Coconut peel was the best performing starchy residue, and granule waste was confirmed as a viable substrate when used inside the tray bioreactor, and combined, both the biological and engineering results support the development of sustainable, low-cost SF platforms. Right? Well, we would like to leave you with a quote from our personal favorite scientific, right? The physicist Richard Feynman, that says, "Study hard what interests you in the most undisciplined, irreverent, and original manner possible." Well, we hope this little project inspires you to pursue other applications of solid-state fermentation, and we hope to see you soon. Thank you.